Hello, welcome again. We are solving IIT Jee physics. The topic is current, electricity and circuit analysis. Question number 27 from year 2019 is two electric bulbs rated at 25 watt, 220 volt and 100 watt 220 volt are connected in series across a 220 volt voltage source. If 25 watt and 100 watt bulbs draw power P1 and P2 respectively, then options 1 P1 is equal to 9 watt, P2 is equal to 16 watt, 2 P1 is equal to 16 watt and P2 is equal to 9 watt, 3 P1 is equal to 16 watt, P2 is equal to 4 watt, 4 P1 is equal to 4 watt and P2 is equal to 16 watt. So the resistance of the 25 watt bulb is your resistance is, we know that the power is VI and V is I by R, oh sorry IR, and so I will be V by I, so power will be given by V square by P. Okay, okay, or we can say that P is equal to V square by R, or R is equal to V square by P. Okay, so V voltage is here 220, so and power is 225, so the resistance of first bulb is 1936 ohm. Similarly, the resistance of second bulb, that is of 100 watt bulb, is 220 square by 100, or that is 484 ohm. Okay, now these bulbs are connected in series, so it can be taken as resistance instead of bulb. So now two resistances are connected in series, so R1 and R2 are in series, and 220 volt has been supplied. So the equivalent resistance will be R1 plus R2, that is 1936 plus 480, so that will be 2416 ohm. Okay, and the voltage supplied is 220 volt. Okay, and the current drawn is V by R equivalent, so that is 220 by 2416, or it will be 0.0191 ampere. Okay, so the current will be at 0.019 ampere, or we can say it is 220 by 2416. Okay, so that is the current drawn. Now the power drawn from the 25 watt bulb is your VI, or I square R1. Okay, so it is your I square R1, and I is same for R1 and R2. So I is your 0.091 or 220 by 2416. So power drawn from the first bulb is your 220 by 2416 square into resistance of first bulb 1936, that is 16 watt, and power drawn from the second bulb is, again this current is now 220 and 2 by 2416 square into 400, that is 4 watt. So the power drawn is 16 and 4 watt. Okay, so answer is your option 3. Okay, next option 3 is the right answer. Next, a galvanometer deflection when the key K1 is closed but K2 is open. So this is key K1, it is closed and K2 is open, equals theta naught. See figure. On closing K2 also and adjusting R2 to 5 ohm, this R2 to 5 ohm. Now it has, now K2 is also closed and resistance R2 is adjusted to 5 ohm. The reflection in the galvanometer, becomes theta naught by 5. The resistance of the galvanometer is given by, neglect the internal resistance of the battery. Options are 122 ohm and 2 12 ohm, 3 5 ohm and 4 12 ohm. So this is your battery, this is your 220 ohm resistance, this is your galvanometer, and the resistance of galvanometer is we have to find out. So now when K1 is closed and K2 is open, so these R1 and the resistance of galvanometer are in series. Okay, so let I be the current flowing, then I R1 plus I, suppose this resistance is R. Okay, then I R1 plus I R is equal to that voltage supplied. Okay, so so I R1 plus I R is equal to V, so I is equal to V divided by R1 plus R, and R1 is the 220. Okay, so I will be V divided by 220 plus R. Now when both K1 and K2 are closed, so these two resistance will be in parallel, and this parallel resistor will be in series to this. Okay, so and voltage applied is same. So let I1 be the, let I2 be the current flowing in this 5 ohm resistance, and I1 be the current flowing through the galvanometer. Now it is given that the I is now the deflection of galvanometer is theta naught by 5, and initial deflection was theta naught. So it means the 1/5 of the previous current that I is flowing through the galvanometer. So it means I1 is I by 5. So as this is 5 ohm, okay, and resistance of R, so suppose resistance of galvanometer is your R, okay, resistance of galvanometer is R, that we have assumed earlier, okay. So the voltage drop across this and voltage drop across this will be same. So it means I1, here I1 is going, here I2 is going. I1 into R is equal to I2 into 5. I2 into 5. So I1, so I2 is equal to I1 R divided by 5. So I1 is your I. Okay, I1 is your I1 is your I by 5. That is, so deflection of galvanometer is now theta naught by 5. Initially the deflection was theta naught, and the current was I. Now the deflection is theta naught by 5. So the current flowing through is I by 5. So I1 is your I by 5. So it will be I2 will be I R by 25. Okay. So now I2 is your I by 5, and I2 is I R by 25. Okay. Now let I is current flowing through this. So I is equal to I1 plus I2. Okay. So I is equal to I1 plus I2, and I1 is I by 5. Okay, and I1 is I by 5, and I2 is IR by 25. So that is equal to I, total current. Now the potential drop is through this. Now the potential is same. So the potential drop through R1 and potential drop through G is total potential drop, or that is the potential applied, that is equal to potential applied. So the potential drop will be IR1 plus I1 R, okay, or I1 is equal to I by 5. So this will be IR1 plus I by 5 into R. Now I is equal to total current is just this I by 5 plus IR by 25. So I we can put here, and R1 is 220. So and this is I by 5, and this is R. Now this is your V. Now the potential applied is same as it that in previous case, and the potential applied in previous case was 220 plus R into I. So it will be I 220 plus R. Now equating this and this, we can solve it for I. Okay, so the now we can solve it for I. Okay. So sorry, we can solve it for R because I will cancel out. I is same, I is there in every term. Okay, I will cancel out, and now we can solve it for R. So R will be your 22 ohm. Answer is 1. Just we have to find out I when K1 is connected. Okay, and then this will be I by 5, and from the same potential drop we can find out I2. Okay, and then we find out the potential drop 220 plus potential drop here and here, it will be equal total, and total is given by this also. So equating these two, you can get R. Okay.